Hello everyone. Now we are going to see the second type of transducer from chapter 3 transducer. The transducer which we are going to see now is called as piezoelectric transducer. So what actually is the piezoelectric transducer we will see. So definition is the piezoelectric transducer is an electroacoustic transducer used for conversion of pressure or mechanical stress into alternating electrical force. So, as the name indicates piezoelectric, piezo is nothing but it is a type of crystal materials which are used for the conversion of pressure or force into an electric voltage. That is why it is called as piezoelectric transducer. So, how in piezoelectric transducer the conversion of a force, pressure or stress is done into an electrical voltage. That is for converting the pressure, force or stress. It may be pressure, it may be force or it may be stress. To convert any of this physical parameter into the electrical one, that is into electrical voltage, the transducer which is used is called as piezoelectric transducer. So here the conversion process is done without any external supply, and that is why piezoelectric transducer comes under the category of active transducer, which is a self-generating one. So here you must keep in mind the transducer which is used to convert pressure or force into the electrical quantity is called as piezoelectric transducer. So sometimes when we come across the physical quantities such as pressure, force or stress, so these quantities are not possible to measure, or these quantities are unable to measure. So to measure this type of physical quantities, the transducer used in the instrumentation system is called as piezoelectric transducer. So here is a simple diagram of a piezoelectric transducer. So in piezoelectric transducer, for converting pressure or force into electrical quantity, the crystals called as the piezoelectric crystals are used. So these piezoelectric crystals are nothing but some sort of asymmetrical crystalline structures which are naturally available. Also they are man-made. So this crystal or these materials are used, and these materials have a property that when they are suspected under stress, or when they are pressurized by something or force is applied on them, this particular crystals develop an electromotive force around themselves, and this electromotive force is then measured as the electrical voltage at the output of the piezoelectric transducer. So here in this diagram you can see this is particularly the structure of piezoelectric material. So on this circular structure, on both sides stress is applied, that is from upper and lower side stress is applied, or this material is pressurized. As this material is pressurized, it produces the electrical voltage which is measured by an voltmeter, analog voltmeter connected over here. So the same phenomenon is used in the piezoelectric transducer, or same is the working of piezoelectric transducer. Now we will see the actual construction of piezoelectric transducer. So here the piezoelectric word means electricity produced by the pressure. So as I have already told, that is some crystal structures are used to produce the voltage in the piezoelectric transducer. So the this quartz is nothing but a naturally available piezoelectric crystal. So quartz is nothing but naturally available crystalline structure which when suspected to the pressure produces the electrical voltage. And also we have the other materials such as Rochella salts, ammonium dehydration phosphate, lithium sulfate, dipotassium titrate. These are the examples of man-made crystals which can also be used as a piezoelectric crystals. So what is the thing, when this type of crystals are pressurized, they produce the EMF around themselves, which is then measured as electrical voltage. So here in this two diagram, the construction of piezoelectric transducer is shown. So we will see this diagram first. So here at the center of the transducer there is a pressure port. By using this pressure port, the force or pressure is applied to the piezoelectric crystal. So once the force or pressure is applied to this pressure port, it is then passed through something called as force summing member. So there are two spring-like structure, you can see over here. These are two spring-like structure which are called as force summing member. So whatever is the force coming from this pressure port, these summing members will move in up or down direction according to the quantity of force. Means whatever quantity of force is applied, according to that these force summing members are flexible to move upper side or lower side, or they can move right or left. So As they move, they apply the same amount of pressure to this crystal. So crystal is connected directly to the force summing member. So when pressure comes from this pressure port, it goes on to the force summing member. Force summing member gives that particular amount of pressure to the crystal. So this crystal is nothing but quartz crystal. It may be other crystals such as Rochella salt, ammonium dehydration, etc. So we know that the crystals has the property that when they are suspected to pressure, they produces the output voltage. So now here, when the pressure is given to the crystal, this crystal produces an electromotive force around itself. The electromotive force which this crystal is producing around itself is proportional to the quantity of pressure applied. Means what? If we are applying more amount of pressure from this pressure port, the crystal structure will produce more EMF. If we apply less pressure, this crystal will produce less EMF, and so on. So whatever is the amount of EMF produced by this crystal, the same amount of output voltage we will get, which is taken out of this crystal with the help of the two terminals. And then lastly, the base is connected. Base is connected to support this particular type of transducer. So this is how the piezoelectric transducer work. Same is shown in this particular diagram. That is, in force is applied from the pressure port. We have a piezoelectric transducer. Means we have a crystals over here, that is quartz crystals or other type of crystals. So when the force is applied from both the sides, so from the upper side, this particular crystal produces the voltage or EMF, which in turn gives us the output voltage. So by learning or by seeing this diagram, we can understand that accordingly to the pressure applied, or depending upon the quantity of pressure applied, we get the output voltage. So this particular piezoelectric crystals is used to measure the pressure, or is used to measure the force, or is also used to measure the vibrations. So in particular, most of the cases in instrumentation systems, we cannot measure the force or pressure, and most of the devices works on force and pressure, etc. So to measure what amount of force or pressure is given to a particular instrumentation system, the transducer used is called as piezoelectric transducer. So this is how the piezoelectric transducer converts pressure into electrical voltage. So one thing you have to remember, whatever the electrical voltage is produced by this piezoelectric transducer is the alternating electric voltage. It is not the same electrical voltage or constant electrical voltage, but it is the alternating electrical voltage, or alternating electric voltage is produced by this piezoelectric transducer. Next, we will see the applications of piezoelectric transducer. So piezoelectric materials cannot measure the static values. These are primarily used for measuring surface roughness in accelerometers as an vibration pickup. So piezoelectric transducer, as it gives us the alternating electric voltage, so they have a high frequency response. The alternating voltage has the high frequency response, and that is why they can be used in accelerometers and as the vibrations pick up. So accelerometers are mostly used in the vehicles. Also they are used in the mobile devices to calculate the vibrations. So in that particular applications, we use piezoelectric transducer. Second, these are used in the seismographs to measure vibrations in rockets. So they are also used in the seismographs to measure vibrations. In strain gauges to measure force, stress and vibration. So strain gauges are nothing but the instrumentation type devices. So in strain gauges to measure the force or stress, we use the piezoelectric transducers. The next, they are used by automotive industry to measure detonations in engines. They are also used in automotive industries. And they are used in ultrasonic imaging in medical applications. They are used in ultrasonic imaging in medical applications. Also they are used in the underwater applications such as sonar, etc. to calculate the vibrations. So this is all about the applications of piezoelectric transducer. And lastly, the advantages and disadvantages. So advantages are, these are active, that they do not require external power, that already I have told you. So therefore they are self-generating. And the high frequency response of this transducer makes a good choice for various applications. So as they have high frequency response, they are used in many applications. And disadvantage is that temperature and environmental conditions can affect the behavior of transducer. So if the temperature of the particular environment or particular surrounding changes, then it may affect the output or behavior of transducer. And second, they can only measure changing pressure, hence they are useless while measuring static parameter. That is, when the pressure or pressure which we are applying to the piezoelectric transducer, if that is changing continuously, then only it can give us the alternating electric current. Otherwise, if the pressure is constant, that pressure cannot be calculated by a piezoelectric transducer. This is its disadvantage. So this was all regarding the piezoelectric type of transducer. Thank you.